Alright, last 10 questions. Question 51. Find the angle in radian and in degree that intercept an arc of length 28 cm in a circle of radius 21 cm. You will round your answers to the 10th of a degree. I guess there's a slight, it shouldn't be answers, right? Well, we'll see why, but right here it should be answer. And it has to be clear, answer in degree, okay? You will round your answer in degree to the 10th of a degree. Well, let's see what's going on here. So you have a circle. Its radius is 21 centimeter, and it intercepts an arc of length 28 centimeter. So I'm gonna put my arc right here. Here is the intercepted arc. The angle is a central angle. It's an angle whose vertex is at the center right here, okay? So S equals 28 centimeters. And the question is, find the angle in radian. Well, an angle in radian, let's call that theta. An angle in radian indicates, the measure of an angle in radian is a number that indicates how many radii you can place inside the intercepted arc. How many arc can I place right here, right? So to find the number of radii inside the arc, basically you have to find how many 21 there are in 28, right? So of course you can, if you remember the formula, it's faster, but it's also very good to understand the formula. So theta is the number of radii that I can place right here in S, so it's 28 divided by 21, okay? And of course you should simplify that, so divide by 7, so it's 4/3. 4/3. Now you don't really need a unit. If you want, you can write rad, okay, but actually normally we shouldn't write a unit because it's a ratio of two quantities with the same unit, okay? So when you write an angle in radian, you don't put the unit. When you write an angle in degree, you must write the units. I have to say, here and there, I haven't been completely consistent with the degree when I wrote the unit, okay? Anyway, so here's the measure of the angle in radian, right? Here we go. All right, now we also have to find it in degree. So in degree, what do we do? So in degree, we write 4/3, that's a measure in radian, and we go from radian to degree. So you have to multiply by either pi over 180 or 180 over pi. You go to degree, so it's 180 over pi, okay? Again, how do you remember that? Where you're given an angle in radian, so what are you multiplying by to find degree, okay? If you're given an angle in radian, let's see. If you multiply that by pi over 180, let's write the unit. That's rad over degree, deg. Well, nothing simplifies, and that's gonna give you some, actually rad squared over degree, right? And that's nothing, so it's not this one. But if you multiply by 180 over pi, then here you get degree and here you get radian. And so right here you can simplify radian and you get something that's called degree, okay? This is just a mnemonic way of remembering it, or actually it's looking at the units, okay, also, so it's not completely mnemonic. Okay, so let's see what's going on here. 3 by 3, 180 by 3, 60, and so it is 240 over pi degree, okay? So this is the exact answer, but in this problem I want you to simplify to the unit, so no, to the 10th. So I need to get my calculator. Okay, so when I do that, let me put first of all an approximating equality. So it's about 76.4 degree. 76.4 degree, okay? And this is the measure of the angle in degree. Here we go. All right. Next one. The Washington Monument is 555 feet high. If you stand a quarter mile or 1,320 feet from the base of the monument and look at the top, find the angle of elevation to the nearest degree. Alright, so here is the Washington Monument, right here. Here we go. Right here. Here's the ground. And here is you. So, of course, you have a skirt. And you're looking at something. So here's what your measuring tool. And here we go. Oh, you got some kind of big feet here. Oh well. Okay. So the distance here. Let me change color to put there. So the distance between you. Okay. Well, let's suppose. Well, okay. We want the height. To be exact, and I have done problem like that before. I should have put the altitude right here, the height of your eyes. Okay, but okay, anyway, whatever. Here we go. Let's say you're measuring with your feet. Okay. Oops, missed the top here. So you have to look at the top and just go there. Here we go. And here we go. So here's the right triangle. Now, careful. Where's that? Okay, well, this is from the base of the monument. You stand, so it's right here, okay? 13-20 feet. Don't put it here. It has no meaning here. There's no way you can figure out this distance, I mean, directly, right? Okay. Then the height, of course, it's right here. That's 555 feet. And so let's figure out this angle there. Okay, so of course we're going to be playing with the opposite and the adjacent, so we're playing with the tangent. So the tangent of theta is 555 divided by 1,320, right? But we don't want the tangent, we want the angle of elevation. So if you remember, this is the output, right? This is the output, and this is the input. And I'm looking for the input. So what's going on when you're looking for the input? Once you know the output, so let's call that B right here. I know this and I want X. How do you find X? Well, what function goes from the output back to the input? Well, the function is the inverse function, right? So X is F inverse of B, right? Of course, it needs to have an inverse. We have played with these function on some homework problems right here. So theta right here would be 10 minus 10 inverse of 555 divided by 1320. Now be careful, this has nothing to do with the reciprocal of 10, okay? Don't confuse this with the reciprocal of 10. This has nothing to do with 1 over 10, okay? 1 over 10 of something. This is a 10 inverse. The reciprocal would be the reciprocal would be this right here. You take something and you put the negative on right here. Now that's a reciprocal, okay? All right, actually, let me erase that. Okay, here we go. So you find this in your calculator. So you have to do second 10, right? It's on top of your calculator. So let me type that. Make sure you're in degree. Make sure your calculator is in degree mode. 555 divided by 1320, and 10 minus 1 of that is 22.8, so it's about 22.8 degree, okay? Round to the nearest degree. Round to the nearest degree, so I guess I would say 23 degrees. Sorry, make sure you read the question, okay? It says to the nearest degree right here. Okay, all right, good. Next, 2 observer 15 100 meters apart on a straight road. Measure the angle of elevation over the helicopter hovering over the road between them. Okay. If the angles are 32 and 51, 32.5 and 51, how high is the helicopter and how far is it from the nearest observer? Okay, alright, so the first thing to do right here, of course, is the representation of that. So here's a road. Here's the two observer 1 and observer 2. And here's the helicopter. Don't put it in the middle. If you put it in the middle, that would be an extra assumption. Okay, so here I'm going to put it right here. Okay, here we go. Let's do that. Let's just draw a triangle and put the points afterwards. Here we go. Here we go. Okay, so the two angles are 32.5 and 51. So if I look at the figure, it looks like this should be the smallest one, 32.5. Of course, it's not drawn to scale, and 51. Okay, and the question is, okay, well, also the distance between the two observers is 1500 meters. So that distance right here is 1500 meters. Okay. How high is the helicopter? So we're looking for the height of the helicopter. So I'm gonna have to give a name to that, right? Height right here, h. And we're also looking for how far is it from the nearest observer? Okay, I guess okay, this is a bit confusing, and on the exam I'm gonna have to be clear. How far is it? The it refers to the helicopter, right? So my question right here is, do they want this distance right here? Because the helicopter is not here, or do they want this distance? I believe they're asking for this distance, okay? Alright, it makes sense, right? It's the distance between the helicopter and the observer, therefore it's going to be this one. I should assume it has to do with the angle 51 and not the angle 52, okay? That's going to be further, but we can compute all of that. So I need to give a name to one of the two distances right here, not both, okay? So I'm going to call this one x. Why not both? Because don't call this one y, or else you're going to carry an extra equation. You can simply call it 1500 minus x, right? If you call it y, then you're going to have the extra equation x plus y equals 1500. Okay, and I'm looking for h. So here, here's a picture with two variables, x and h, okay, let's find. All right, so we've encountered this type of problem before. Let's just write some equation, right? So what do we have here? I'm going to express that the tan of 51. I'm not going to write degree, okay? It should be degree right here. Is, okay, here, I said I won't write it, but I end up writing it. Is h over x, and I'm also going to express that the tan of 32.5 is, oh, gosh, is h over 1500 minus x, right? Okay, and now I know what to do right here. I'm going to solve the both equations for h. So here I have h equals x times tan of 51. And here, if and only if, actually, alright, really, it's not exactly an if and only if. I multiply by a variable expression, it's more an if then. It doesn't matter, okay. H equals 1500 minus x times tan of 32.5. Okay, all right. So let's equate these two quantities. So we have, and I'm going to expand this side because I know I have to solve for x. I'm going to get one equation, y variable, and because I want to solve for x, I'm going to have to move the x on both sides, on the same side, right? But to grab this one, I'm going to have to expand. So here we go. X times, we've done that several times on various problem. X times tan of 51 equals 1500 times tan of 32.5 minus x times tan of 32.5. Gonna have to mop my document, all the symbols that I've right here. Look at that. Oh, look at that. Oh, look at that. Poop, poop, poop. Okay. So let's move the x on the same side. So x times tan of 51 degree plus x times tan of 32.5 degree equals, right, 1500 times tan of 32.5. Okay, so we want to solve for x, therefore we need to put it together. So you factor x and then you're going to divide. So two more steps. I'm really detailing everything here. I'll write here. Okay, I'll write here. You know what, this has to go. Okay, here we go. All right, so let's factor x, as I said. So x times tan of 51 degree plus tan of 32.5 degree equals 1500 times tan of 32.5 degree. Here we go. And so last step. So x is equal to 1500 times tan of 32.5 divided by tan of 51 plus tan of 32.5. Okay, all right, at this point, here, you know what, I'm gonna open this calculator so you can see. Okay, we're gonna have to be careful here about the second question again. So I'm gonna call this A, oops, this A, and get away, and this right here I'm gonna call B. We can compare, but I'm fairly sure that it's gonna, well, actually I know. Okay, here's the calculator, but let me see. Here we go. Large screen. Okay, let's clear everything. Clear. Okay, and let me go back to my document first off, which is right here. Okay, so I'm pretty sure that this is going to be the shorter length, okay, because the angle is bigger right here. So let's plug that in the calculator. So let me see. Yeah, I remember. Okay, here's a calculator. So I need to open the parentheses, right? So why? Because there's a top and a bottom. 15. Actually, I didn't need to open this one right here. Sorry. 1500 times the tan of, and I believe that was 32.5 at the top. Okay, that's closing the parentheses for the 10. And again, I really made a mistake when I said that. It doesn't matter. I need to open. I don't need to open the parentheses at the top here. I'm going to show you. Actually, I can get rid of it. Right? You don't need the parentheses here because of the order of operation. You're going to do the multiplication. But now, what you're going to need to do is, like when you divide here, divide by here. You would be making a mistake if you were not opening the parentheses. 10 of 51. Close the parentheses for 10 plus 10 of 32.5, close the parenthesis for 10, close the parenthesis for the denominator, and actually I'm not going to push enter because I have no idea what the mode is on this calculator, so let me check that. Yep, you see what I mean? My mode has to be degree here, so here we go, enter, okay, and now I can push enter. and I find 510.5 feet. So x is about 510.5, don't forget the unit, feet. Okay, all right. Now let me see, let's get A and B. So so I know H, I got H now. So for A it's gonna be the sine, right? Right, so the sine of 51 equals H over A. So A is H divided by sine 51. I got H in my calculator, right? So let's go back to the calculator. So I'm just going to divide this by sine of 51, right? That's H right here. So I'm going to divide it by sine 51. And I should find a number that is bigger, longer than 510, right? It's a hypotenuse of the triangle, so it should be longer. And I find 656.9. So let's go. So A is about 656.9 feet, right? Sorry, it's really squeezed right here. Let's do the same on the other side. The sine of 32.5, in case you're not sure, is H over B. So B is equal to H divided by the sine of 32.5, and that is about, so let's take the calculator, and I want, so look what I'm gonna do, okay? Second entry, no, that's not what I want, right? Second entry, yes, that's what I want. Let me push enter and let me divide this, divided by the sine of 32.5 parenthesis, and that gives us 950.1, which is what we said. Okay, so I don't know, apparently something paused right here, I'm not sure why, but the second one, as I showed you right here, is 950.1. So there we go, 950.1 feet. So I'm not going to circle that because that's not what I need. Okay, all right, it's a bit tight right here space wise. Okay, let's clean up. Actually, you know what, this is 22 minutes, right? Almost 25, and it is Friday, and it is 5 o'clock. So as you can see, I really don't have a life, which is, I shouldn't say things like that. I really have a life, but I am gonna go to my spin class, therefore I'm not gonna record the end of that right here, and 24 minutes is enough for a video, right? Is it clean? Yeah, alright, so now I'm gonna go and suffer for an hour, because the teacher that teaches spin and core is a torsionary. She tortures us. Okay, I'm gonna stop right now, and I'm going to my spin class, and I'm really excited, and I'll be back around 8 o'clock, but I'll post that tomorrow. Hasta la vista.